Okay, so today we're going to be talking about the surface areas of pyramids and cones. So again, just like with cylinders and prisms, it works the same way. The difference is a pyramid and a cone meet at a point at the top, so they only have one base. So you see in the picture how we have just one base labeled because the top of the pyramid is a point. And you still have your right pyramids versus your slanted pyramids. So this one is at a right angle, so it would still be that. One thing to notice is a regular pyramid has a base that's a regular polygon. So that's how you know that it's regular. And then the height, you have the altitude that comes from the center to the top of that point at the top of the pyramid or cone. And then the slant height is the one that goes from the top, but it comes to the base edge, not the center of the base. And then we have our two formulas here, lateral area and surface area. Lateral area is just 1/2 of the perimeter times the slant height. And surface area, again, is lateral area plus, but this time only one area of the base because there's only one base. So again, that lateral area will be 1/2 perimeter times slant height plus area of the base. Again, whatever that shape of that base is, find the area. Okay, so for our first example, we're asked to find the lateral area of a regular hexagonal pyramid. Remember, hexagon has 6 sides. So over the perimeter, you would have 6 sides times the base edge of 9. So all those edges are 9. So for perimeter, 6 times 9 is 54. And then a lateral height, so that's a slant height of 7. So we have 1/2 times the perimeter of 54 times the slant height or lateral height of 7. So you have 0.5 times 54 times 7, and we get 189. So the lateral area is 189 centimeters squared. Again, area, so units are squared. Okay, so now we're going to find the surface area. We have a pyramid here. It looks to have like maybe a rhombus base, so kind of like a square would work. So what we know is that the altitude is 9 inches. I'm going to draw this to the side so you can see it. The altitude is 9 inches, and the slant height is 11 inches. And then what we know is because this is the center, if we want to know the length of this side right here, this is what we have to find. So if we do Pythagorean theorem and get this piece, we could double it, and that will be our side length. And then we'll know what we need to finish off the problem. So we do 9 squared plus x squared equals 11 squared. 9 squared is 81. 11 squared, I think it's 121. Yep, minus 81, and we get 40. So x squared equals 40. Take the square root. We get x equals 6.32. So that is this piece right here, 6.32. So we have to double it to get our full length. So 12.65 really. So 12.65. If you have 6.4 because of that number, you could keep that. So 12.65. So the perimeter, all of these are going to be the same because it says it's regular. So for perimeter, we have 4 sides that are 12.65 a piece. So times 4. Let's see, 12.6. I rounded, so let's just go ahead and round. 50.6. Okay. For area of the base, because if we're doing surface area, we also need area. For area, we would do 12.65 times 12.65, base times height. So for area, we get 160.02. And we really could just go with 160, but I'll go ahead and round it here. So now for surface area, we have 1/2 perimeter of 50.6, slant height is 11, plus the area of 160.02. So 1/2 or 0.5 times 50.6 times 11 is 278.3. Plus 160.02, and that's 438.32. And again, 438.3 would be more than sufficient of an answer. It's probably even more likely that we would do 1 decimal place, but I already carried it. So that's our surface area. Now let's check our units. We have inches, so inches squared. So the surface area of this regular pyramid is 438.3 or 0.32 inches squared. Okay, so now we're going to find the surface area of a regular pyramid, and the reason I wanted to do this one separately is because this is that 1/2 ANS to be able to get that area, so that's going to be really important for us to keep solving. So first off, let's just go ahead and find perimeter, because we need that. Remember our formula that I'll write over here is SA equals 1/2 PL plus A. So that's what we're working towards. So for P, there are 1, 2, 3, 4, 5 sides, all at 4 inches. So the perimeter is 20. So we have P. Now we need L and A. For L, you need to come across and then make that right there. And this will be our L. Well, this right here, if you don't notice, is the apothem from our last chapter, I believe it was. So that also is right here just to help you see. So we have, let me show you. This is 4 inches, which means that this apothem right here splits it into a 2-inch piece. And that's really all that we know. And so our job is to find the apothem. We don't necessarily need this length for any reason. So we need A. Now this angle right here, that's half of the central angle. So for the central angle, remember we take 360, we divide it by the number of sides as a pentagon, so divide by 5, I think that's 72, let me just check. 360 divided by 5, 72. Okay, then remember this is halved because of that apothem, so divide it by 2 and get 36. So this is a 36-degree angle. And the opposite is 2, adjacent is what we're looking for, so that's tan. So tan 36 equals opposite 2 over adjacent A. So we multiply by A, divide by tan 36. So to get the apothem, 2 divided by tan 36, 2.75. Okay, the side length is 4, and the number of sides is 5. So now for area, it's 1/2 ANS. So 1/2 times 2.75 times 5 times 4. So 0.5 times 2.75 times 5 times 4. And that's 27.5. Okay, slant height. This apothem and that height will help us using Pythagorean theorem. So the altitude is 7. We're looking for the slant height, and we just found that the apothem was 2.75. So we do 2.75 squared plus 7 squared equals L squared. 2.75 squared is 7.5625. We'll just keep all the 5, 6 maybe. Plus 7 squared is 49. So we need to add that and get 56.56. Take the square root and get 7.5. We're going to round a little bit. So the slant height is 7.5. So now we have everything we need. So surface area equals 1/2 perimeter. That's 20 times the slant height, 7.5, plus the area, 27.5. So 0.5 times 20 times 7.5 is 75, plus 27.5, and we get surface area equals 102.5. Our units were in inches, so our answer is 102.5 inches squared. So it works the same way we just did the last problem. You just have to use that 1/2 ANS, so it's a little bit harder because you have to do a few more steps. Okay, so now we're going to talk about cones, and really the difference is just it's got a circular base. So for a right cone and an oblique cone, the differences are a right cone is going to have a right angle And the axis and altitude are the same, where an oblique cone is going to be more slanted. So the axis, what's from the vertex to the center, is not actually a right angle. So the altitude would be that straight line there. And then the slanted side is still the slant height. We have a vertex at the top, so that's all the same. So for the formulas for lateral area and surface area, again, we could use those formulas we used before, but since the circle always has that same base, you can be a little more specific. So for lateral area, it's just pi RL. So that's like saying the perimeter or circumference times the slant height, like it was before, half of it. That's why you don't have to have the D. And then for surface area, pi RL plus pi R squared, again, that being that one area of the base. Okay, so we're gonna go ahead and find the lateral and surface area of this cone. So we have the radius is 0.8, and then this is the slant height, which is 2.2. Remember our formula we just talked about, lateral area is pi RL. So that's what we're finding first. So we have everything we need. So lateral area equals pi times 0.8 times 2.2. So pi times 0.8 times 2.2, and we get 5.5. We're just going to round. 5.5, and the units were millimeters squared. So that's lateral area, nice and easy. For surface area, we have pi RL, which we already know the answer to, plus pi R squared. So we're just going to go ahead and fill in that pi RL as 5.5 rather than working it again, although you could, plus pi, radius is 0.8 squared. So 5.5 plus, let's do pi times 0.8 squared, and that's 2.0. Let's just leave it nice and easy. So 2.0, so then we add that plus 5.5, we get 7.5. So surface area equals 7.5 units are millimeters squared. So a cone actually tends to be pretty easy. So you have your lateral area of 5.5 millimeters squared and your surface area of 7.5 millimeters squared.